Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on manually configuring default routes on IPv4 networks. Alright, so let's read our objective for this lab. It says a default route is used to send packets that are destined for a location that is not listed elsewhere in the routing table. If a router were required to store a specific route to every destination network on the internet, routing tables will grow exponentially and router performance would deteriorate. Default routes help keep routing tables small. A default route is also known as a gateway of last resort or default gateway. In this lab, you will learn to manually configure default routes on a Cisco router and Cisco switches. So if we take a look at our lab topology, we can see that we have two routers that connect up to this internet cloud connection. We have two layer 3 switches and we have our access layer switches as well. And when we have PCs connected out to the access layer switches as well. So basically what we're going to be doing in this lab is configuring default gateways, or not default gateways, gateway of last resorts or default routes on these routers right here to be able to get out to the internet. So basically what a default route tells a router is if you do not have any specific route within your routing table for a destination network, send this unknown destination traffic to this IP address, which will be another router that will get you to the destination IP address that you want to get to. All right. So let's go ahead and take a look at the commands that we're going to be doing in this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have IP default gateway IP address, which configures a default gateway IP address to which traffic destinates to remote networks will be forwarded. We have IP route destination prefix mask, IP address or interface type, IP address, which establishes a static route. We have ping IP address, which sends an ICMP echo request to the specified address. And we have show IP route, which displays the IPv4 routing table. All right, so we can take a look at our IP address information table. This is good information to have for mapping the topology with the correct interface and IP addresses for each interface. We can reference this table as needed throughout the lab. So we're going to keep my lab topology in the top left. We're going to be doing our lab readings in the top right, and we're going to be doing our configuration down here at the bottom. All right. So task 1, it says manually configure default routes on Cisco routers. It says in this task, you will manually configure and test default routes on Cisco routers. So it says from router 1, attempt to ping IP address 192.0.2.1, 192.0.2.2, and 192.0.2.3, which are IP addresses that exist elsewhere on the internet in this lab. Do the ping succeed? All right, so on router 1, let's ping 192.0.2.1. And while these pings are going through, let's take a look at our IP address table. We can see that those pings are failing, by the way. But we can see 192.0.2.1 is a loopback 0 interface on the internet router. All right. So all of these loopback IP addresses are loopback addresses that are configured on this internet cloud. Okay. So now let's do a ping to 192.0.2.2. Can we ping that loopback 0 interface? And we cannot. We're getting periods on our pings, so we know that those are not successful pings. All right, and let's try that 2.3. And are we able to ping that 2.3? We are not able to ping that loopback address either on the internet cloud. All right, so number 2, it says on router 1, display the routing table. There's a path to 192.0.2.0 network exists. All right, so on router 1, let's do an enable. Let's do a show IP route. All right, show IP route. And if we take a look at R1's routing table, we do not see any specific networks listed in the routing table that correlate to 192.0.2.0. So that is why these pings up here were failing. R1 does not have a route in its routing table to the 192.0.2.0 network, okay? So number 3, it says there are 2 different destinations that you can configure when manually configuring a default route on a Cisco router. What are these destinations and what are the differences between them? So when you are configuring a default route on a router, you can either specify the exit interface or you can specify the next hop and exit interface. If you just specify the exit interface, ARP will have to occur every time you send a packet over that link, and therefore ARP uses more CPU, so that will cause a higher ARP cache on the router. But if you specify the next hop IP address, then ARP only has to occur one time, and then from there that can be saved. So let's see what Boson is going to say. It says when a default route is manually configured on a Cisco router, the default route destination can be specified as either the next hop address or the local interface to which packets should be sent. However, creating a default route to an interface causes the router to send ARP requests for each destination address that it sends through the default route, which can cause high processor utilization and create a large ARP cache. So yes, that is exactly what I just explained. So number 4, it says on R1, configure a default route through the interface that connects R1 to the internet. What network prefix did you use and what subnet mask did you use? So let's go ahead and configure the default route now on router 1. Let's do a configure terminal. Let's do an IP route, and we want to specify all IP addresses and all subnet masks. So we're going to do O.O.O.O, O.O.O.O, O.O.O.O. All right. And it wants us to specify the serial 01 interface. So serial 01 interface as the exit interface and hit enter. All right. So we did a network mask of all zeros to encompass all networks, and we used a subnet mask of all zeros to encompass all subnets. So that is why we use the O.O.O.O for the subnet mask and the network prefix. All right, so on number 5, it says on R1, display the routing table. What new entries do you notice there? So let's do a do show IP route now. And as you can see, we have a static route down here at the bottom that lists O.O.O.O, the static entry that we just typed in on this router. And we can see our gateway of last resort is specified as well. All right, so we can see our new entry. So on number 6, it says from router 1, attempt to ping the IP address, all of the IP addresses that we just tried to attempt to ping before. So let's try that. Let's do an end, and let's go back, and let's try to ping 192.0.2.1. Those pings are successful this time. Let's try .2.2. That is successful as well. And .3 is successful also because we configured that default route. All right. So now R1 has a route to get to these networks. So R1 is able to ping these networks. All right. So number 7, it says from router 2, attempt to ping those same IP addresses. Do the ping succeed? So let's pull up R2. We're on R2 now. And let's first do a ping to 192.0.2.1. Let's see if R2 has any default routes. And it looks like it doesn't, because these pings are failing. All right, let's try that 2.2. Probably are going to have to do a mirror configuration over here on router 2. All right, those pings fail, and let's try .3. and those pings are failing as well. All right, so number 8, it says on router 2, display the routing table as a path to 192.0.2.0 exists. All right, so let's do an enable. Let's do a show IP route. If we take a look at the routing table, this looks identical to what router 1 had before. We do not have a path to, it's not identical as router 1's routing table. Don't get that misconstrued with what I'm saying. I'm basically saying that this router does not have a path to 192.0.2.0. All right. So on number 9, it says on router 2, configure a default route through the next hop IP address that connects the internet router to router 2, which has an IP address of 203.0.113.5. How does this command differ from the one that you issued on router 1? Well, this time we're specifying a next hop IP address. On router 1, we just put in the exit interface. So we did not specify the next hop. So that is going to be the difference between router 1's configuration and this configuration that we're doing on router 2. So let's do a configure terminal. Let's do an IP route. Well, if I can type IP route, O.O.O.O.O, O.O.O.O.O, and we want to do a next hop of 203.0.113.5. All right, and hit enter there. So now on number 10, it says on router 2, display the routing table. What entries do you notice there? How do these entries display differently from the manual configuration that you gave on router 1's routing table? All right, so let's do a do show IP route on router 2. And we can see we have this static route, but this time we can see the next hop instead of just the exit interface. All right. We can also see the gateway of last resort has been configured on router 2. So number 11, it says on router 2, attempt to ping the same IP addresses that you did before and do the ping succeed. So on router 2, let's do an end. Let's try to ping those same IP addresses that we did before. So .1 does work, .2 works, and .3 works. So that default route gave this router a route to get to the 192.0.2.0 network, and as a result, now router 2 can ping those loopback interfaces on the internet cloud. All right. So number 12, it says both D-Switch 1 and D-Switch 2 in this lab are layer 3 switches on which IPv4 routing has been enabled. Therefore, both D-Switch 1 and D-Switch 2 are also routers. Default route on Cisco layer 3 switches can thus be configured the same way they are configured on Cisco routers. On D-Switch 1, configure a default route through the interface that connects D-Switch 1 to router 1. All right, so let's go to D-Switch 1. All right, and the first thing I want to do is do an enable. All right, and I want to do a show CDP neighbor to see the connection that is to, we want to see the connection that is to having a brain freeze. On D-Switch 1 and D-Switch 2 in this lab are layer 3 switches. Therefore, D-Switch 1 and D-Switch 2 shall also be routers. Default routes on Cisco layer 3 routers can thus be configured the same way they are configured on Cisco routers. On D-Switch 1, configure a default route through the interface that connects to router 1. Okay, see, I want to see the interface that connects up to router 1. All right, so we can see that is the Fast Ethernet 01 interface. So I want to do a configure terminal, and I want to go into interface, Fast Ethernet 01. Oh, I don't even have to do that actually. Let's just do an IP route of O.O.O.O. Destination prefix of O.O.O.O. And I want to do that through the Fast Ethernet 01 connection. All right. So now it says on D-Switch 1, attempt to ping the 192.0.2.1 loopback 0 interface, which is on the internet cloud. That's the ping succeed. So let's do a do ping to 192.0.2.1. And that ping is successful on D-Switch 1. All right. So number 14, it says on D-Switch 2, configure a default route through the next hop IP address that connects dswitch2 to router 2. So let's pull up dswitch2. Let's do an enable. Let's do a show CDP neighbor to see the connection to router 2. That's through the fast Ethernet 01 interface. So let's do a show IP interface brief. And we can see that the fast Ethernet 01 connection, we can see its IP address. All right. So let's take a look at the next hop that dswitch2 will have to router 2. It looks like that will be 198.51.100.9 because that is the fast Ethernet 10 connection on router 2. All right. So that looks to be correct. So let's remember this IP address 198.51.100.9. Let's go to router 2. Let's do a configure terminal. Let's do an IP route to 0.0.0.0, 0.0.0.0. We want to do a next hop of 198.51.100.9. All right, hit enter there. Now it says on dswitch2 attempt to ping the 192.0.2.1. Does the ping succeed? So let's do a end. Let's do a ping to 192.0.2.1. And those pings are successful. So we are able to ping the loopback 0 interface on the internet cloud. All right. So now let's go ahead and go into task 2. It says manually configure default route on Cisco switches. All right. So it says although not technically default routes, because layer 2 switches do not perform routing, layer 2 switches can be configured with default gateways. Default gateways are similar to default routes in that they provide a path to forward packets sent to unknown destination. Default gateways are typically configured on layer 2 switches and end user devices. However, the method for configuring a default gateway on a layer 2 Cisco switch differs from the method of configuring a gateway of last resort on a Cisco router and layer 3 switches. In this task, you will manually configure a default gateway on A switch 1 and A switch 2. So it says on A switch 1, attempt to ping 203.0.113.1 an IP address on the internet router. The ping should fail. So on A switch 1, let's pull it up and let's do a ping to 203.0.113.1. And we can see that these pings are failing on A switch 1 up to the internet router, and that is because it does not have a route to reach that network. Okay, so right here it says on a router, the IP default network address command can be used in place of the IP route command to configure a gateway of last resort. If IP routing is disabled on a router or layer 3 switch, you can configure the gateway of last resort by issuing the IP default gateway address command instead. This command is also used on layer 2 switches to configure a default gateway. On A switch 1, configure a default gateway that relies on dswitch1's VLAN 100 interface, which has an IP address of 10.10.100.1 as a next hop address. So on A switch 1, let's do an enable. Let's do a configure terminal. Let's do an IP default gateway of 10.10.100.1. All right, and hit enter there. Now it says on A switch 1, attempt to ping that same IP address on the internet router. So let's do an end. And let's do that ping. And we can see now our pings are successful because we configured a default gateway on this layer 2 access switch, and that gave it a route up to get to the internet address. All right, so let's do the same thing over on A switch 2. Right here on number 4, it says on A switch 2, configure a default gateway that relies on dswitch2's VLAN 200 interface as a next hop address. So let's do that. Let's do an enable. Let's do a configure terminal. Let's do an IP default gateway of 10.10.200.1. Hit enter there. Let's do an end. Let's do a ping to 203.0 192.168.113.1. And now those pings are also successful to be able to ping the internet cloud from a switch 2, because we configured the default gateway on the layer 2 switch on a switch 2. So we see the default routes, which are configured on layer 3 devices, and we see the default gateway that are configured on layer 2 switches and also in devices. All right, so let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.